Welcome back, everybody. This is the video for April 14th. Hope you guys had a good spring break. Please remember, whenever you're doing notes and homework from now on, you're going to take out a brand new sheet of paper. You'll write down all the notes. You'll try the homework problems that I put on the board or show on the video, and then you're going to upload that as in your document in Google Docs for our classwork. Okay, so it's really important that you do that by 7 a.m. the next day. So you guys need to do this by April 15th by 7 a.m. So one day after, you guys got the whole day and all night to do it if you're a night owl. But I need you guys to make sure you guys try the homework before I post the answers. So on April 15th, I'll be posting the answers to these homework problems. You get credit again for trying your best at them. I can't check everybody's homework every single day for every single problem. It's a participation grade. I'll just kind of check to make sure you're somewhat doing it. It is your responsibility to check the homework answer keys and to let me know if there's any big issues that you can't figure out on what you did wrong or whatever, okay? So make sure you are doing your best, and then hopefully this stuff is sinking in because you will need this next year in geometry. All right, you guys, so we have radicals. We spent last week trying to reduce radicals, but we also have to know how to add them. Now, or add or subtract. When we add or subtract radicals, the first thing that we want to do is make sure each radical is in its simplest form. So we try to break them down. Well, 3 is a prime number, so we can't even break that down at all. So is 7. And then again, 3 and 7, we see a little repeat. So whenever we want to add or subtract radicals, number 1 is you make sure all the radicals are reduced. In this case, they already were for that. Then you look to see what we call like terms. You kind of treat radicals just like you would variables. So I can color code up here. And whenever I look at this, well, this one has a square root of 3. So I'll consider him a blue piece. Are there any other square root of 3s up there? And I actually see one there. But remember, we got to look what's in front of it as well. So it's actually -9 square root of 3. So those will get to go together. The next thing that we see is a square root of 7. So what type of square root of 7 is? It's +2 rad 7. And again, you can say rad instead of square root. And this is positive rad 7, but there's an invisible number there. So anytime a radical does not have a number in front of it, you can put the invisible value of 1. So it's really +1 rad 7. So now you guys, I'm just going to get 2 different parts of my solution. The blue pieces, or the rad 3s. I'll take the numbers in front and add or subtract them. 5 minus 9 makes -4 rad 3. So you add or subtract the numbers in front of the radical, leaving the radical alone when adding or subtracting. So then we look at our rad 7s. +2 plus 1 is +3, and you keep the rad 7. So in order to add or subtract radicals, you kind of treat the radicals like you would variables. In variables, when we combine like terms, we added or subtract the coefficients, that was numbers in front of letters, and we left the letters alone. Well, now we're add or subtract the numbers in front of the radical, leaving the radical alone. Okay, we're only going to do 3 examples today, so let's move on to number 2. Number 2 is a little bit harder though, because all the radicals might not be in simplest form. So I have 5 rad 24 plus 8 rad 3 minus rad 12 plus 7 rad 6. So if you looked at this problem right now, you might think there are no like terms. This has to stay exactly the same. But we have to do step 1 in this. Step 1 is reduce each radical. So we try to do a prime factorization tree for each radical. 24 is a composite number, so we can break it down. Now I like to do the smallest number that fits into 24. I know there's lots of different answers. 8 times 3 is 24, but I don't want that. I want 2 times 12. 2 is a prime number. 12 is 2 times 6. 2 is a prime number. 6 is 2 times 3, which are both prime numbers. So now I know that I can look for pairs. Pairs come out as singles, and singles stay trapped. So what I have is I have a pair of 2's that gets to come on the outside. Now I like to draw the arrow because if there's a number already out there, we got to know what to do with it. So when I draw my arrow and bring it outside, I notice there's already a 5 in front of there. Well, the 2 stays trapped and the 3 stays trapped. So I have to get a new quote-unquote radical problem. So on the outside, 5 was already there, and I bring out a 2. 5 times 2 is 10. I put a square root symbol and I look at what's trapped underneath there. A 2 is trapped, times a 3 is trapped, rad 6. 2 times 3 is 6. Then I put a plus symbol. I look at 3 and it's prime. I actually don't have to break it down. So 8 rad 3 has to stay 8 rad 3. There's a minus symbol, and I see if I can break down 12. 12 is a composite number. It's 2 times 6, 2 is prime. 6 is 2 times 3, prime and prime. So now I look for pairs, and I notice there is a pair. But luckily, there's nothing out in front of it. So when I bring this pair of 2's out in front, I don't have to do any multiplication. I simply get to put a 2 on the outside, and I put my square root, and the 3 is trapped. Now, the last one, I put plus, and 6 is a composite number. But when I break it down to prime factorization, 2 and 3 are both prime numbers, there are no pairs. So that means that they both stay trapped, and 2 times 3 is 6, so rad 6 doesn't reduce. So I keep 7 rad 6. And now I look for like terms. You guys, just as the problem before, but without color coding now. Maybe we can do like a little like shape or some squiggles or whatever to see like terms. Well, here's a rad 6, and there's a rad 6. So I get to combine those. 10 rad 6 plus 7 rad 6 is 17 rad 6. And then there's a rad 3. There's a rad 3. So positive 8 rad 3 minus 2 rad 3. 8 minus 2 is positive 6. So I put a plus symbol for positive, 6 rad 3, and that is my final answer. All right, guys, we're going to do one more problem. And then you're going to get some practice problems. Now, you want to make sure that you do know what perfect square roots are. That will really help us out with number 3. So on number 3, I have 5 rad 2 plus rad 81 minus 3 rad 8. Okay, I try to break down each radical. Well, 2 is a prime number, so that's going to stay rad 2. So I got 5 rad 2. All of that just comes down and stays the same. There's a plus symbol. But this is kind of an important problem. 81 is a composite number, but I probably should not take the time to do that. If you type in the square root of 81, it is a perfect answer. It's no longer a square root anymore. The square root of 81 is just 9. So this square root is just 9, and it's no longer a square root. Please make sure you remember that perfect square roots no longer have the radical symbol. Then there's a minus symbol that comes down, and 8 is a composite number, which is 2 times 4 and 2 times 2. Prime, prime, prime. And we look for pairs and singles. We got a pair of 2's that get to come outside, and we have a single 2 that has to stay trapped. But on the outside, a 3 was already there. So 3 times the 2 that came on the outside is 6. You put your square root or radical symbol, and this single 2 has to stay trapped. Now by looking at that, we have like terms. So you guys, I could take the rad 2 and the rad 2 part together. Now, there's 2 acceptable answers to this. The first acceptable answers, you could take 5 rad 2 minus 6 rad 2 is negative 1 rad 2, and then you can put your plus 9 at the end. Now, actually, I guess there's 3 acceptable answers, because an alternate version of that is you don't have to show the 1. So you could call it negative rad 2 plus 9. Remember, a number in front that's 1 can be invisible. But the way that we would prefer to write it is, if there ever is a whole part which doesn't have a radical, you put that first. So instead of putting the plus 9 at the end, I'll put the positive 9 first, and then I'll do like terms. 5 rad 2 minus 6 rad 2 is minus or negative 1 rad 2, and I don't have to show the 1. So really, they're all the same answer, it's just the order that you put them in. You guys, please make sure that you started a brand new sheet of paper. Every single day we start a brand new sheet of paper. We put the date at the top, we show our notes, and we do our homework, and then you guys will upload that on your Google Doc to the classwork, and then you get full participation for the day. Here will be your 4 problems for homework that you'll try. And hopefully that is zoomed in well enough. So please make sure that you do those 4 problems. After you are done, do the classwork Google Doc, upload all your work, and show it to me. Have a great day, you guys. Hope you're all staying happy and healthy. It's your boy, Mr. P.